Hello everybody, welcome to Vidman. In this video, we are going to learn about the polynomials from 9th standard CBSE syllabus. Before starting about the polynomials, let us know about the difference between algebraic expression and the equation. Expression and equation, we can see the difference. I have given the examples. Here equals is there in the equations, and they are algebraic expressions or equations because they are the combined form of the constants or the variables. So the letters are called the variables and these are the constants. The numbers are the constants. So let us know about the number of terms which we have in these algebraic expressions. The first, second and third, they have one term. Even though we have 3 and x, here 3x square y z power 7, they are considered as one term. 3x is considered as one term, 3x square y z power 7 is considered one term, m is considered one term, because 3 and 3x is nothing but 3 into x. So when we have into, then that is considered as one term. And now the other examples, m plus n, it has two terms. Two terms because m and n are separated with plus. If the two terms are separated with plus or minus, then we consider them as the separate terms. Here 2p square minus 6q cube plus 15r power 4, it is having 3 terms. So this is having 3 terms. Now let us, these terms are having they are having constants and the variables. Constants are the numbers and the variables are the letters. So the variables can take any value. Like if we have 1 kg mango will cost 60 rupees. If we take in that way, and different people take different quantity, like somebody takes 2 kgs, they have to pay rupees 120. So this is 60 rupees will be constant, and this will vary 2 kg, 3 kg. According to that will be 60 into 2 or 60 into 3. So this 60 is constant. Now let us take a look about the what is a polynomial and what is not a polynomial. Every algebraic expression is not a polynomial. Every algebraic expression is not a polynomial. I have given the example x square 7a plus 4b square and 25m square n cube. These are the polynomials. But cube root of p, m cube plus 1 by n cube, 7x to the power half. These are not polynomials. Why they are not polynomials? Since the power of them is not a whole number. Okay. But here the polynomials, these powers, x to the power 2, b to the power 2, a to the power 1, m square, n cube. These are all the whole numbers, but here the power is half, and this will be, if it goes to the numerator, it becomes n to the power minus 3. So minus 3 is not a whole number. This is p to the power 1 by 3. So this is not a whole number. Therefore, these algebraic expressions are not the polynomials. So it is very clear from this example that polynomials means those algebraic expressions which are having the whole numbers as the power. Let us take a look about what are these. That is monomial means single, one. So it is one term, and then binomial means 2 terms, trinomial means 3 terms. Okay, so here one term I can take it as 2m is one example for monomial. 2 terms we can take it as 2m plus 3n as 2 terms binomial. 3 terms I can take it as a plus 2b minus c as trinomial. So I can take even plus also. So now this though we have understood why they are not polynomials. It can be p to the power 1 by 3. It is p to the n to the power minus n minus 3, and this is x to the power half. So they are not whole numbers. Powers are not whole numbers. Now this is the definition for polynomial. Polynomial is an algebraic expression which has whole number as its power or degree. Example, here this is 25x to the power 8 and then x to the power 7 plus x to the power 6 plus 2. Here all the terms, all the powers are the whole numbers. Powers of constants are whole numbers. Therefore, it's a polynomial. But x plus 1 by root x is not a polynomial because this denominator x term is having the root of x, that is x plus, I can write this as x plus 1 by x to the power half. So this is not a polynomial. Now let us take a look about number of terms in a polynomial. If I have a polynomial which starts with x to the power 5, 3x to the power 4 minus 2x to the power x cube plus x square plus 6x plus 4x to the power 0. This has 4 terms. So this will be 5, 4, 3, 2, 1. This is one set which has 5 terms. And then this is the last one, that is a constant. So it will have 6 terms. Now if I take the polynomial which starts with x to the power 100, then x to the power 99 continuously like this, then it will have this much is 100 terms plus 1. This is plus 1 term. So it will have 101 terms. Now this one, 7 to the power 7b cube plus 3. This has only 2 terms even though we have b cube here. So b cube is there, but why it has only 2 terms? It has only 2 terms because this we can see 7b cube plus 0b square plus 0b plus 3b to the power 0. Now this is power 3, power 2, power 1, power 0. Now this is 7b cube and then plus 3. The other 2 terms here are having the constant as 0 and 0, due to which we have only 7b cube plus 3, and hence this polynomial has only 2 terms. Now we will go for the constant polynomial. We have seen these are the polynomials which are having the numbers also and the constant also. Now what is this constant polynomial? Constant polynomial are like this: 1, 2, 35, 98, 309. So these are all the constant polynomials, and even 0 is a constant polynomial. Why it is so? Because this is also a number. 0 is also a number and which will not change. So that is a constant polynomial. And they are not combined with the variables. So these are not combined with variables like 2x, 35y square. So this will not be there, right? So they are called the constant polynomials. And 0, the polynomial which is 0 is called a 0 polynomial. That's all. Now we will look into what is degree of polynomial. Degree of polynomial is the highest power of a variable in a polynomial. So highest power of a variable, that is called a degree of the polynomial. Now we have a polynomial here, 6a to the power 8 plus 7b to the power 7 plus c plus 4. Now the constants are left out, means we are not considering the power of the constants, we are considering the power of the variables, that is a power 8, b power 7 and c. In that the highest power is 8. So the degree is 8. And now in this case, root 3 x cube plus 2x square plus 3x plus 6. In this case the highest power is 3. So we take that as the degree of the polynomial. Now The degree of non-zero constant polynomial is what? We know that 0 is also a constant polynomial, but it is a zero polynomial, right? This is zero polynomial. Now, we are taking the degree of non-zero constant polynomial. In this case, 91 is there. So, 91 we are writing it as 91 x to the power 0. Anything raised to the power 0 is 1. So, we don't have the variable in this case. And if we are having variable, we take it as x to the power 0 or x to the power, here 8x to the power 0, 9y to the power 0, 100t to the power 0. So, these are having the, these constant polynomials are having the degree as 0. Okay, like x to the power 0, 8x to the power 0, and the degree is 0. Now, we will look into the next one, finding the degree of a monomial. Monomial means single term. How do we find out the degree of a monomial? In this case, it is highest degree. When we have plus minus in between, it is a polynomial. Polynomial in the sense, polynomial means it is algebraic expression which has more than 2 terms with the degree as whole number, right? And it is a monomial. How do we find out? We find out, we'll add up all the degrees. This is 2, the degree of A is 2 and the degree of B is 1. Nothing, degree is not mentioned, means it is 1. And the degree of C is plus 3, we'll add all the degrees and we'll get 6. So, this is the degree of this particular monomial. And we'll take a look about the other one, next one. You must have got it already, right? So, this is 3 plus 2 plus 5. So, total it will be equal to 10. So, this is the degree of this particular monomial. Now, we will go for the next one, polynomial in one variable of degree n for any natural number. So, what is the polynomial in one variable? One variable in the sense we have here x square plus x plus 2. So, x, the same letter should be there. It should not be like x square plus y plus 2. So, these two are different. X and y are different. So, they are 2 variables. This will be 2 variable. But we are talking about one variable, just one variable. So, I have taken here x to the power n. X to the power n minus 1, x to the power n minus 2, like that. So, now we will look into this. How do we write it? The degree n and the number, natural number n, right? So, that can be written as an x to the power n plus an minus 1 x to the power n minus 1, an2 into x to the power n minus 2 plus etc. a1 x to the power 1, a0 x to the power 0. So, x to the power 0 will be equal to 1. So, ultimately we write it as a0 or a0. And this a0 or a0, a1, a2, etc. up to an are the constants. They are the constants like 1, 2, 3, what it can be any value. Now, if a0, a1, a2, etc., an, all these are equal to 0. Like an plus n minus 1, an minus 2, all these are equal to 0. Then what? So, 0 into a to the power n plus 0 into x to the, 0 into x to the power n plus 0 into x to the power n minus 1 plus 0 into x to the power n minus 2 plus etc. plus 0 into x to the power n plus 0 into x to the power 0. Now, the whole thing will be equal to 0 because 0 into 1, 0 plus 0 into 1, 0, 0 into 1, 0 into x to the power n, 0. So, anything multiplied with 0 will be resulting 0 and adding all those zeros will give 0 itself. So, this is a 0 polynomial or constant polynomial. Alright. Now, degree of the 0 polynomial is not defined. We have to remember this. Degree of the 0 polynomial is not defined, but the degree of the constant polynomial is defined and it is 1, right? Degree is 1 for constant polynomial, but the zero polynomial, no, not defined. We will go for the next one, that is, it is based on the degree of the polynomial. We are classifying the polynomial. It can be a linear polynomial, it can be a quadratic polynomial, or it can be a cubic polynomial. Linear polynomial is that wherein the polynomial has its highest degree as 1. Here 1, this is 1 and this is 1. So x plus 5, the degree is 1. X to the power 3x to the power 1 plus 9, degree is 1. And here degree is 1, degree is 1. So those polynomials which are having the degree 1 are called linear polynomials. And now quadratic polynomials are those where the degree is 2, the highest degree is 2. So they are the quadratic polynomials. So 9x square plus 5x plus pi, in that the highest degree is 2. Y square plus 3, highest degree is 2. 3t square, degree is 2. M square plus 5 by 6m, the degree is 2. So they are called quadratic polynomials. And then the next one, cubic polynomials. Cubic polynomials are those where the highest degree is cube or 3. Highest degree is 3. Root 3 x cube plus 7x square plus x plus 1. So highest degree 3. 9 by 11 x cube, highest degree 3. 15 x cube plus 1, highest degree 3. L cube plus 2l square plus L plus 15, highest degree 3. So these are the examples for cubic polynomials. Now we will go for what is a coefficient. Coefficient is that which is multiplied to the constant, multiplied to the variables. And we have here 9x square. So the coefficient of x square is 7, which is beside that. Then here n, what is the coefficient of n? It is mp, both. And in this polynomial, the coefficient of x to the power 5 is minus 1, because this is minus x to the power 5, and if the coefficient is not mentioned, then it is understood that it is 1 x to the power 5. So minus 1 is the coefficient of x to the power 5, then y to the power 4, it is 6, then y, it is 1. So these are the coefficients of different coefficients of different terms. We have different terms. So coefficient of these 3 terms I have mentioned in this box. Now we will go for polynomial in one variable. Yes, I have already mentioned. We have the example here, 4x square minus 5x plus 8. X, they are the same letters, and t power 4, and we have root 5, other terms cube, square and t power 1. They are not present. So since they are not present, it is understood that it is 0t cube will get 0t square and 0t, and which is not there in these, but still this is one variable polynomial. And the next one is also one variable polynomial, because we have root 3m plus 1 by 16, and we don't have any other term. So this is only 1m, and it is a one variable polynomial. We will take a look about the non-examples. This is a to the power 9 plus 6b to the b square plus c to the power 4. We have 3 variables. So this is not one variable. And in this case, 3 root t plus, minus root 2t. In this case, root t is t to the power half, which is not a whole number. Hence, this is not a polynomial, Therefore, we don't consider it as a polynomial, and we don't consider its power also, or the degree also. And then the next one, we have L minus 6 by L square. So, which can be written as L minus 6 into t to the power minus 2. If this goes to the numerator, t to the power minus 2, which is not a whole number. Therefore, this is also not a polynomial in one variable. It is not at all a polynomial. This is not a polynomial, because we don't have whole numbers in these two cases. Okay, so now you can solve the exercise very easily. Thank you for watching. Please do subscribe to my channel and share it, and please hit the bell icon so that you can get the notifications whenever I upload my videos. Thank you once again. Till then, take care.